Hi guys, just a quick video because I want to leave it in HD format. There are the LEDs we're using sitting in front of the circuit we're using. The circuit has two components, an inductor and a solid state relay. The switch of course we don't need. I will be tracing how the circuit is hooked up tomorrow, but it is very small, so I'll have to put my big seeing eye goggles on. The two LEDs we are running quite brightly. They are hooked in parallel, so that is doing an excellent job at running those LEDs for the power input we are using. Our solar panel, we are running off a super cap at the moment, 2.5 farads. Okay, our input current is 1 milliamp, and it does drop down to 0 from time to time. Of course I won't do it now that we are filming it. And our input voltage is 0.946 volts. Now here is what we have managed to find when placing the solar panel in the correct position, which is very touchy to find this. Now it looks a bit like a tornado, excuse me, so we're going to call this a tornado oscillator. Now what I want to know is, can we get the output wattage from the scope shot? We are on 0.5 volts on the volt divisions, and we are on 2 microseconds on the time divisions. Our duty cycle is about 40% on time, and the voltage across the LED when the LEDs when they fire up is 2.9 volts peak. That drops down to about 2.5 volts at the end of the on time or the on cycle. So do we average that out to say, even if we went low to 2.6 volts times our 1 milliamp input, and then times that result by 40% to get our output? I'm not sure. I'm still learning when it comes to scopes. But our input is 1 milliamp, 0.941 volts, and across the globe the LEDs, it peaks at 2.9 volts, drops off to about 2.5 volts at the end of the 40% on time, or our on cycle, and then it goes to our 60% off time. And you will notice also that it drops below 0 volts across those LEDs when it switches off, which is interesting. But there's our tornado, and well, I want to hear someone else's thoughts on the output power across those LEDs compared to the input power we are putting into the unit. And the brightness of the LEDs seem to tell us a little story as to the input power that we are using. Okay, the other thing I did notice, the lower this voltage drops on the super cap, the higher the peak voltage goes across the LEDs when it fires up each pulse. At 1.5 volts, the peak voltage across the LEDs is about 2.4 volts. At, as you can see, 0.937 volts, the peak voltage is getting very close to 3 volts now, but about 2.9 volts. Okay, that's it for me. I'll get this uploaded and we'll take it from there, and as I said, tomorrow I will get that circuit drawn up for you guys to replicate, and I'm hoping to be able to go a larger scale, but I am unable to find solid state relays on my supplier's website. Alrighty, it's cheers from the Tin Man for now.